Equations of motion. First one, velocity time relation, v equals u plus at. We have three sets of equations of motion. Okay, one of them is velocity time relation. What we'll do first to derive this equation is we'll take a graph, which is a velocity time graph. Okay. Here time is along x-axis, velocity is along y-axis, and both the axes meet at the origin. Okay, let's assume that a graph is plotted for an object in uniform motion. That means the increase is directly proportionate to each other, correct? It will be a straight line. Okay, so we'll take that and we'll name the points A and B. A is the value that corresponds to its initial velocity. B corresponds to final velocity. At initial velocity, time is 0. That is why A is on y-axis. And then B is where time is, let's say, t. Okay. So what I'll do now is I'll take a perpendicular line to the x-axis. Okay, and I'll name this point on the x-axis as C. C corresponds to the time at final velocity. Correct? You got this? Okay, we'll move on. We'll keep this graph to the side now. What I'm going to do is I'm going to plot another perpendicular line. Okay, this line will come from A and it will be perpendicular to BC. Right? It will be parallel to the x-axis. Okay, the point it meets on BC, I will name it as D, and the velocity of B, okay, the corresponding value of velocity of B will be named as E. Okay, now we need to take some certain quantities. Okay, so what we'll do, we'll take E is final velocity, right? That is the corresponding value. So OE will also give me final velocity, correct? The measure of OE represents final velocity. We also know from the graph that OE equals BC, right? So OE is V, OE equals BC equals V. Okay, we'll keep this value in mind. Next, A corresponds to the initial velocity, correct? Like we told in the start. Okay, so OA equals DC equals U, which is initial velocity. Let's look at that on the graph. OA equals DC, which is equal to initial velocity. Okay. And OC equals AD equals T. Okay. OC is on the x-axis. AD is the exact same measurement. So that also corresponds to the time taken, which we will name as T. Alright. Now we'll take this as a table so that when we are substituting, it will be easy for us to know the values. Okay. Then we'll take the graph, so we can refer to it when we are calculating. Okay, so let's start deriving. For this derivation, first thing that you have to do is you have to take the distance of BC. Now where is BC? BC is here. BC. Okay, the distance of BC is BD plus DC. Am I right? So first we'll write that down. BC equals BD plus DC. Now you know that BC equals OE equals final velocity V and DC equals OA equals initial velocity. Correct? So we'll substitute that in the equation and we have V equals BD plus U. Okay, now if I need to find what BD is equal to, I will take U to the other side of this equation. Correct? So BD equals V minus U. Now we'll keep this in mind and now take your attention to AB. AB is the slope of this graph. Okay, and a slope of a graph usually tells you the ratio between its y-axis value and the x-axis value. Okay, so if I take a ratio of velocity by time, it gives me acceleration. Right, so AB represents the acceleration of this graph. Okay, and acceleration is velocity by time. Correct, so for this AB, its corresponding velocity and corresponding time should be taken. Okay, so let's substitute and we'll take the equation. Acceleration is velocity by time. Substituting, you will get BD by AD because BD is the corresponding velocity value. AD is corresponding time value. Okay, now you know that BD equals V minus U. You just derived that. And AD is equal to OC is equal to T, which is time. So we'll substitute both these quantities. Okay, acceleration we will take as small a. So small a is equal to V minus U by T. Okay, so I don't want this division symbol to be here. So what I'm going to do is I'm going to multiply a with T. So that will give me AT equals V minus U. Okay, now I'm going to take U and put it on the other side of the equation. So minus U becomes plus U. Okay, so V is equal to U plus AT. And this is the equation we had to derive. So what equation is this again? It is the velocity time relation. Okay, and the equation is V equals U plus AT. It's very important that you remember these equations as it is. Okay, and how to derive them as well. Alright, apart from this, we have two other equations. We have position time relation, which is S equals UT plus half AT square, and we have velocity position relation, which is 2AS equals V square minus U square. For both these equations derivation, we will be using parts of the first velocity time relation equation. Okay, we will be using that equation in substitutions for the two other equations. So the first one is very important.